Okay, so we have a problem. It says that problem statement says, given the root node of an N-array tree, create a function to print out the pre-order traversal of its node's values. The function will have the following signature: void pre-order node pointer root. And this is like some like additional information. So basically, like what's going to be useful in this problem is like the val member variable and like the children vector uh, member variable. Everything beyond is like, at least like for the solution that I came up with, like is not that important. It's just like giving you some like additional background information about this like node class. Um, and so basically, like I'm gonna read like test cases. Input represents the level of order traversal of an n-array tree. Each group of children from left to right, it's separated by no value. Each level is separated by no value. In your pre-order method implementation, you will print the node's values at each level with the level number. In our main method, we will directly call pre-order method. We expect the output of your pre-order to match the above format. Um, yeah, it's basically saying like you don't need to implement main. So you basically have to implement a function, the function using the signature, uh, and basically like print like the pre-order traversal of the tree. Now, something I wanted to make sure that we all like understand is like the concept of like an array tree, and I wanted to give an example using like a three array tree. So basically, like if you had like a three array tree, uh, for each node, you can have at most three like child nodes. So like for example, like this node that stores the value 7, it has three nodes like as its children, you know? So but then like this node with like 4, it has like only one child. And then this like 5 has like two children, 2 has like three children. Like an n array tree is basically like a tree where each node can have at most, it doesn't have to have, but at most like n like child nodes. And that's just like some information I just wanted to make sure everyone like knows, like are aware of. uh and basically another thing, like pre-order traversal, we what this means is that basically like we print the root value, and then we start printing the like each child's value from left to right. And the solution that I want to talk about here, I'm sure there's like other ways uh, to approach this problem, but one way that I found like useful, like that works, is like this recursive approach. So what you want to do is you pass in the root, like when the function, like basically like, when you call this function, you call it with like the very root of the tree. You print the root's value, right? And if the root does not have children, we return like this is the base case. This is what's going to stop our function from like infinitely like calling itself again, like recursively calling itself again and again. If we don't reach the base case, like if we still have like if the current root node still has children, then we go to this else clause. What this basically does, it makes like recursive, like it calls pre-order on each of the children for the current root. So it makes like each of the children the root for like a new like pre-order call. Okay, I needed some water. Uh, but I'm going to demonstrate how this function works. You basically like let's say we pass in this node like with the value 7, right? This is like the tree's root. We pass it in on our first call, and then we print its value. Its value is here, hold on. Its value is 7, right? Now 7 has 3 children, and then we visit each one from left to right because it's like stored in the vector. So then 4 we print four's value because like 4 is basically like our next call to pre-order. We're passing in like this node, like storing 4 as the root. So then we're gonna print 4. Now 4 itself has like children, like at least like one child. So we're gonna call like pre-order again, uh, on like this like one child of 4. So we're gonna print 4, and then after like we print 1, 1 doesn't have any more uh like children. So what in this scenario, in this function, like in this call, we basically reach the base case. So it's like once we reach the base case, we're gonna return and we're gonna go back up. We're gonna go back up, and we've already like 4 doesn't have any more like children. So we're gonna go back up. We're gonna go to 7, and then because 7 still has like 2 more children that we haven't like uh basically dealt with yet, uh we basically want to continue going like towards the right. So the next call, we're gonna call pre-order with like the node storing 5. So we're gonna print 5, and basically like speeding this up. Like 5 has 2 children, so we're gonna visit 9. We're gonna print 9. 9 doesn't have any children. We're gonna go back up. 5 still has a child, so it's like we're gonna call again with 3. We're gonna print 3. 3 doesn't have any more like children, so we're going back up. Uh, there's no more children of 5, so we're gonna go back up to 7. 7 still has like a child, so we're gonna visit like 2. We're gonna call 2 like the function with 2, and then we're gonna print 2. And because 2 has like 3 children, we're basically gonna make like 3 more calls. Uh, we're gonna go to like we're gonna like basically visit 6, and then print 6. 6 has no more children. We go back up, and then we're going to visit 8, print 8. 8 has no more children. We're going to go back up, and then 2 has one more child. We're going to visit 0, print 0, and because 0 has no more children, we're going back up, and because we visited all the children of 2, we basically go back up to like 7, and then at this point, uh, we basically like we're done. We've printed all the values in like the pre-order traversal way that this problem is asking us to do.